Are there any questions before we get started today? So hopefully today we'll get through containers, and then we'll either today or most likely on Monday we'll end up doing like command line arguments, files, and random numbers that you can be able to finish your assignment. Okay, so for containers, that X was supposed to be a number, but here's a list of all the containers that exist in the standard template library. There's array, dequeue, forward list, list, map, multi-map, queue, priority queue, set, multi-set, stack, unordered map, unordered multi-map, unordered set, unordered multi-set, and vector. That's a lot of things, right? But in this discussion, we're only going to focus on vector, map, and set. Also, the unordered versions are pretty much similar to the ordered versions, except they're not ordered. In the map and set, the elements are ordered in ascending order. And then in unordered map, they're kind of just an unordered set, they're just in some random order. The unordered maps and sets, it's faster to do individual lookups and insertions into them and removals, but it's slower to iterate through the elements. For a ordered map, it's faster to iterate through it, but it's a little bit slower to add elements into it or remove elements from it. So if you're making the choice on which one you want to use, either an unordered map or like an ordered map, think about which operations are going to be more common. Adding and removing elements, right? Or just looking up elements inside of it? Or are you going to have to go through all the elements multiple times, right? That should lead you to a decision of one over the other. The multi-versions, for both set and map, you're only allowed to have a single element with all the keys have to be unique in the map and in the set, but in the multi-map, the keys don't have to be unique anymore. And so essentially what happens is you could have multiple key value pairs. So all the methods have a couple, all the containers have a couple of methods in common. The first is size, which returns the number of elements in the container. Don't use size of to figure out how many elements are in it. The size of function, what it does is it returns the size of the object in terms of bytes. But due to the fact that the container is not likely to store the elements in the same area that it's allocated for, size of is probably never going to be able to tell you how many elements are in that vector or in that map. So don't use it to figure out how many elements there are. Empty returns true if the container is empty, false if it's not, and clear will remove all the elements from the container. All of the containers have iterators in them, so begin and end, which you've seen before. Const begin, const end, reverse begin, reverse end, const reverse begin, const reverse end. They're pretty much identical to what you've seen on strings. The types might be a little bit different for each of the containers, but begin will start you at the beginning, end will be one past the last thing. Constants, you can't change what you're referencing, but you're able to read the values that are there. Reverse begin and reverse end starts you at the end. I should note, though, that I don't think all of them have the reverse ones. So double check on each container if you try to use like reverse begin or reverse end, but it actually exists. They also have the ability to erase elements in a similar manner. So you say erase and you give it an iterator, and it will delete the element where that iterator is at. Then you can also list a range of iterators, and it will delete all the elements in that range. You can also use regular iterators here, even though the functions to say they take const iterators, because regular iterators are convertible to const iterators. If you erase something using an iterator, consider all of the other iterators that you have going on right now to be invalid after you've removed an element from the container. So if you erase an element from a container and you happen to have some other iterator, you can't use that iterator anymore. It's not guaranteed to be valid anymore. So vector is more or less equivalent to Python's list, except all the elements have to be the same type. Just one second. For C++, or for people that come from C, vectors are like arrays that are resizable very easily, and you can insert elements into them very easily, or remove elements. Yeah. Is this better? Better now? When you declare a vector, you have to say what is the type of the elements that are going to be inside that vector. So you can have a vector of ints, or a vector of strings, or a vector of doubles, right? But vector by itself doesn't name a type. It has to be a vector of some particular type to actually be a valid member type. So if you just see vector somewhere, or like std : vector, that doesn't mean anything. You can't have everything inside the vector has to be assignable. So you can't put things like references into a vector. So a vector of references is illegal. And you couldn't have a vector of constant values. So a vector of constants would also be illegal as well. Any questions so far? Yeah. You can change the contents of the vector or change the value of an element in the vector. If, however, you declare your vector as being a const vector of integers, then you wouldn't be able to change the elements inside of it anymore, or be able to change the vector itself. It'd have to be like initialized to be some fixed size at the beginning, and then your elements wouldn't be changeable anymore. Any other questions? So one thing that can be helpful when working with some of the STL types, the standard library types, is the using statement, because as you've seen back here, like this type is very, very long. And it's very annoying to have to continue to write that type all the time. So what you can do is you can create a type alias, which is just a nickname for that type that you can use instead of having to type out the entire thing each time. To do that, you say using whatever you want that new name of the type to be equals the old type name. And then everywhere you use the new type name, it's like you're saying the old type name. So I might say using matrix equals std : vector of std : vector of doubles. Right? So now instead of having to say this whole type every single time, I can just say I want a matrix called mat. Or I want this function add is going to return a matrix and accept two matrices as arguments, right? But matrix just really means an std : vector of std : vector of double. Any questions here? Yeah. So my matrix is made up of a vector of doubles. Just like when you probably wanted to do a two-dimensional structure in Python, you had a list of lists of numbers, right? Same idea is going on over here. So the question is, what's the difference between an array and a vector? An array, depending on how you declare it, might have a fixed size, which is not resizable. Another declaration might make it resizable, but there's no like .size method defined on it. There's no insert method defined on it. There's no erase method defined on it. It's just a lot more painful to work with and not nearly as nice. So you could basically, like in an implementation, a vector has an underlying array of elements that it's using inside of it, but you don't have to worry about that. So you don't have to worry about when you insert an element into the vector, making sure to move all the elements to the right of that position over one to the right of where you want to insert, or making sure to increase the size, right? When you do vector.insert at some position, the vector will automatically resize itself. It'll automatically move all the elements over that need to be moved over, and then go insert that new value at the position that you requested. So it just makes it a lot easier. But in all other ways, it's more or less like an array. So vector constructors, there are quite a few. If you just say vector with no arguments, you make an empty vector, or like an empty list. Vector of n will make n elements, each constructed using their default constructor. You could say some number and then val, and it'll make n elements inside that vector, each a copy of val. You can say vector some original to make a copy of the original. You can also do vector and then in curly brackets list a set of values. That'll create a vector with those values that you've said. And then you can also copy the values between some iterator range. So you have some start iterator, some end iterator, and you're going to copy the elements that are between that range. So see, here's some examples. Notice that when you use the default constructor, you don't put parentheses after it. That's a really common mistake, and that means something a little bit different. So if you're just doing the default declaration for a variable of some type and you don't want to call a constructor besides the default one, no parentheses. Here we have a vector of doubles, which is 10. So we made space for 10 doubles, and they'll all be initialized to their default value, which is 0. You can have a vector of strings. I wanted 6 strings, all initialized to high, so it's high, 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 6 times inside that vector. We could also have a vector of doubles v4, which is a copy of v2 back here. We have a vector of integers whose type shouldn't be, name can't be v4 because I already used that one. v5, who gets initialized to be the values 6, 8, 9, and 11. And then we also have another vector over here, v6, who we've copied the copied the last 2 elements of v4, which now probably needs to be v5. Yeah, in the back. So the question is, can you use auto here inside the type? No, because the vector wouldn't know what the type of the elements are, right? Especially if you look at like the type of the declaration here for v1, you have a vector of auto, but auto again has to be deduced to be some type. So if you saw auto here instead of integer, what would you choose auto's type to be? I'd have no idea, right? And the compiler will complain at you that it has no idea too, so you can't use auto there. It has to be an explicit type stated. Any other questions? So for element access, dot front will give you the first reference to the first element. Dot back gets you reference to the last element. You can do your vector at some index to get the element at that position, and vector dot at index to get an element at a position as well. The square bracket one, if you go out of bounds, it won't warn you about it, and it won't give you any error, but it has undefined behaviors, so bad things could happen. If you use dot at and you go out of bounds, again, you're going to get an exception, just like with the string. And you're probably going to want to prefer using at over index, or at over using the square brackets. So here we have a vector of ints that's 10, 20, 30. V dot front is 10. V dot front equals 7. We changed 10 to a 7. V dot back is 30. V dot back equals 9. Change the 30 to a 9. V at 1 is 20. Should be V dot at 1, which is also 20. And then we could do something like V dot at 1 equals 99. And that would cause our vector to become. Any questions here? Yeah. So I think your question is, what happens if you, can you do something like this, like int x equals v dot at, not 5, but, right? And so yes, you can do this. This is totally legal. And what's going to happen is we will get the reference to that first value, 99, or the reference to the element at position 1, which is 99, and we'll copy that value over to x. So x is now a completely different variable who happens to have the exact same value, 99. Now, what would happen if you did this? Right? Now, x is just another name for v at 1. Right, so they're the same thing. So if I change x, it's going to change v at 1 because they're the exact same thing. What happens if I do this? What's the type of auto going to become? Well, it's the value of the thing on the right-hand side, and so v dot at returns a reference, so the type gets deduced over here to be integer reference. Right? This is also integer reference as well. So be careful when using autos sometimes to make sure that you know what you're getting. So yeah, super legal. Anything else? Yeah. Okay, so the question is, if my vector was a const vector, right, could I have a reference to the elements inside of it? No. But you could have a const reference to one of the elements inside of it, because since the vector is constant, its elements are constant, you're not allowed to modify them. A regular reference would technically allow you to modify it, so that would be illegal. But a const reference would be perfectly fine. Yeah. Is it possible to put a counter for an element? So you want to count the number of occurrences of some particular value? There isn't anything directly defined on the vector itself, but there are some functions and algorithm that you could use to do that. Yes? Yeah. Because when you're printing it, right, it was using the reference to get the value at that position, right? It wasn't trying to modify it. No, auto's just type gets deduced to be whatever the result of the expression on the right-hand side is. Because at returns a reference. So like when we print at 1, why does 99 show up and not some random thing? Because when you're trying to print the value, right, you're trying to print the reference, you're trying to like read the value at that reference. Right? So like whenever you're trying to, like, remember, like a reference is just a stand-in for the original variable, right? So if I go and I say something like this over here, if I do, you know, cout x, right, I get x's value would go to the screen. If I have an integer reference r, which is equal to x, right, and I cout r, it's also going to print x's value because r is just another name for that variable, and all I'm trying to do is read it. So I get the value that the reference refers to. So what kind of happens here is I look at r, I'm like, oh, well, r is another name for x. So what's x's value? Well, it's 99. Same thing if I replaced this thing down here with v dot at 1. Right, so I go, oh, go to location 1 in the matrix, or the vector, get its value, which is 99, and then display it. And again, I may be wrong, and we can try these things out in a minute to see what happens. If I'm wrong in that it doesn't get deduced to be type integer reference here, but I think it does. So the next set of things is how to add elements. So push back will add an element to the end, and place back will build an element at the end. So in push back you give a value, and in place back you give the arguments to a constructor. And then it will use that constructor to build the value that's there. This can be a little bit faster than building the argument that you want to insert and then pushing it to the back, because that requires a couple of different copies. One, to build the original, and then two, you have to copy it over into the vector. So we end up with like 2 copies of the value. If we used in place, we might only be able to create 1. You should prefer to use in place back if you only want the element to appear inside the vector and you don't already have a copy of the element and you have the arguments to that thing's constructor. But it's more just like an efficiency thing. So if you just prefer to use push back, that'll be fine as well. Pop back will remove the last element. So here I have a vector of strings, which starts as the value just containing hi. I also have another string whose name is name. So I can push back name, so I'm going to get hi class in there. I can also do v.emplaceback, and I can use that string constructor that takes in an integer and then a character for how many times it's repeated. So now I'm going to build at the back of this array I. If I do v.emplaceback, that's going to create the empty string because I'm calling the default constructor here at this point in time. But end up with the empty string here at the end. If I do v.popback, it removes the last element. v.popback again, it's going to remove the I. Any questions here? Yeah. Popback does not return anything. Its return type is void. Anything else? You can also do an insert. So you can give insert some iterator position, some value. You can give an position to insert at, and then some number of elements that you want to insert, and then some value, and then we'll insert that value that many times. You can also have some iterators to where you want to insert at, and then some iterators to some other object of the values that you want to add. There's also insert, and then you can take an initializer list of values, and then you can also do in place to insert a single element. You say some position, and then the constructor arguments that you want to push back. So, for example, here we could do v.insert, and I might do v.begin -3. And so now what we're going to end up with is -3, 1, 2, 3. I said I wanted to insert it at the beginning. We could also do something like v.insert, v.begin +1. And we might want to insert 2 elements that are 8. So what do you think this is going to do? What do you think our vector is going to look like after doing this? It's going to be like negative, it'll be -3, then 8, 8, 1, 2, 3. So I give a number of elements to add, which was 2, and then the value, which was 8. So at index 1 past the beginning, which would be right here, I'm going to insert 2 8s. So you get 8, 8. Then 1, 2, 3. Oops. Then we also could do something like v.emplace, v.end 5. Because we're using integers, it's not going to be very interesting for the in-place call. But this is going to go add a new value to the end of our list, which is just going to be 5. An easier way, since we're adding it to the end of the list, would just be to do a pushback. Then we also could do something like v.insert, v.end. What do you think this is going to do? So where do I want to insert into V? At the end, right? And what am I planning on adding there? 100 and 200. So we'd end up with 100 and then 200. Any questions about insert? Yeah. So the double 8 is from this one right here. So you take a position to insert at, how many elements you want to add, and then the value that you want to add. So I want to insert, starting 1 element past the beginning, 2 8s. So if we look back here, 1 element past the beginning would make my insertion point be right here, right after the -3. and I'm going to add 2 8s, 8 8, and then I have the rest of the elements, the 1 2 3. Anything else? The farther towards the front that you insert, the more expensive that insert is because of how the elements inside the vector are stored. So if you insert at the very beginning of the vector, what's going to happen is the vector is going to have to move all the elements that are there, one element to the right, and then it can insert your value. Inserting elements at the end is very inexpensive because you just have to add that element to the end. So be cognizant of that fact when you're doing your inserts. There are some size methods, so you can resize your vector. You can also say resize and then provide a value. If new size is less than old size, we're only going to keep the first new size elements. If new size is greater than the old size, the elements that we're going to add will be default constructed if no value is provided, or they will be initialized to whatever value is that we set. So you can see that over here I have 1 2 3. If I do v.resize 5, I get 1 2 3 0 0. If I do v.resize 2, I only keep the first two things. v.resize to be a size of 4, the new elements will have the value 10, 1 2 10 10. And the reserve method internally causes the vector to reserve that much space. This will make inserting elements a little bit cheaper, or adding elements a little bit cheaper, because the vector won't have to keep resizing itself, which is a somewhat expensive operation. So we could pre-allocate the space, but it's not actually going to change the number of elements that are inside of the vector. And then when we do our pushbacks, it can use that space that we already created. So it'll go faster. So over here, right, I reserved 10,000 elements, right? But if I ask for the size of my vector, I would still get 1 2 3 4. There's only 4 elements in it, but it has space to hold up to 10,000 things. And so now I go and I push back, I, until we're like entirely full. And that's going to be a lot faster than if we hadn't put this line in here, because the vector would have to keep resizing itself as it added new elements. So the reserve is a bit of an optimization method. If you know your vector is going to end up to be like n elements big, reserve n space to begin with. It will cause your code to run a little bit faster. Any questions here? Yeah. Mm-hmm. So you'd end up with 1 2 10 10 0 1 2 3 4 5 6 7 8 9 10 11 12, all the way up to like 9,999. So I didn't quite reserve as much space as I would need, the 10,004, but I got it pretty close, so it might only need to do like one resize potentially at the very end. Any other questions? Okay. Do you guys want to talk about maps, or you want to do some examples with vectors first? Examples? So over here, the first thing that I'm going to do is, if you want to use vector, you have to include vector. And then I'm also going to make type alias matrix so that I don't have to keep typing vector of doubles all the time. Any questions so far? Okay. So let's say we have a function called add that then takes into const matrix references M1 and a const matrix reference M2. So if I hadn't done this using statement up here on line 9, what would I have had to have written on line 11 instead? Well, again, everywhere that you see matrix, you'd have to replace it with this. So if I hadn't used the using statement, I would have had to write this. It's kind of long, right? And that's why I use that using statement to save me from having to keep retyping that every single time. It can be a really huge time saver. Also, if you ever decide to change the type of matrix, you might only have to change this one line depending on if your other functions still could support that usage. So, have you guys done any linear algebra before? So when we're adding matrices, right, all we have to do is add the elements in the corresponding positions together to get a we have to add the elements in the corresponding positions to get the value at that new element. So like the matrix C, right, equals A plus B. So C at ij equals A at ij plus B at ij, the corresponding indices. So the first thing that we have to do is we have to create a new matrix, right? So what would I use to create a new matrix? Well, I'd say matrix, right? We might call it sum. And we're going to need to initialize it. Well, what should we initialize it to be? Say it again? Yeah, we could initialize it to be another matrix. Maybe we make it start out as being M1, right? So now our new matrix already starts with all those values in it, right? Then we need to go through each of the rows. So for auto reference row in M2. Oh wait, this is not going to work. We're going to have to use indices. So for I equals 0, I less than M2 dot size plus I, J equals 0, J less than M2 dot at M2 dot at I dot size, right? Sum dot at I dot at J plus equals M2 dot at I dot at. And then at the end we can return sum. Any questions? Yeah. So the question is, why am I using unsigned? If we look at the return types of size, they return an unsigned integer. And the compiler will end up complaining about the types not matching if I don't use unsigned over here. It will complain about comparing unsigned integer versus signed integer. And so I'd either need to cast m2.size into an integer, or I could just declare I and j to be unsigned integers. All right, if I change it back, if I just change this to be an integer, it should complain at me if I try to build it. You can see it's like, hey, comparison between signed and unsigned integer expressions. And the error is the sign compare. If I turn it back into an unsigned int, no complaints. Any other questions? Yeah. So, how many of you guys think it makes a new matrix? How many do you think we alter the original? We're actually making a new matrix. So notice here on line 8, we make a completely new matrix whose name is sum. That is a copy of the original, M1, right? And then down here on line 11, we're adding to sum, which is again a copy of M1, and then we return sum. So we make a completely new matrix to be our result. Any other questions? So we just have to add the elements of the corresponding positions together to get the sum, the result in the sum. So if you look at how matrix addition is defined, it's only defined to work on matrices that are the same size. So this wouldn't work if the sizes are different. Right now, what would happen is we'd probably get some out of bounds exception error. But you could do some other checking once we learn about how to implement exceptions, where you could say, oh, these matrices don't have the same size, right? And then you could throw your own exception. Let's say we wanted to print a matrix. What would this function's signature look like? We have to accept the matrix, so const matrix reference matrix. And we probably don't need to return anything, so it'll just be void. Do you guys understand why I'm using references? Any questions on that? So I'm using references because I don't want to copy the objects. Copying the objects is, again, very expensive, especially if these matrices are very large. All I'm planning on doing is reading them. I don't want to have to copy them every time I call this function. I can just work with the original. The reason I have const there is because I'm not planning on changing the matrices that are passed into me. I don't want to be able to change them, and I want to let people that are using my code know that I'm not planning on changing them, and also to allow my code to work in most situations to be able to work on constant objects. So print matrix, how do we go about printing out a matrix? Well, to be able to print, we need to include IOStream. And we'll include vector over here for just safe measure. Actually, probably not. So how would I go about printing out the elements in the vector? Yeah, a for loop. Which type of for loop? We could do an element-based for loop here, right? So we could say for const auto reference row in matrix. And so now I have the row. So how do I go through the elements in the row? Another for loop, right? So for const auto reference element in row. I want to print it out. How do I do that? Cout element, and we'll follow it up with a space. And then after I finish going through the entire row, what should I print? A new line. So my question to you guys right now is, what does auto's type get deduced to be? Again, here's our definition of matrix type. So this first one for matrix for row, what does the auto over here's type get deduced to be? A vector of doubles, right? Because each of the elements of my vector is a vector of doubles, right? So I'm going through each of the elements of this outside vector. So I'm going through these vectors of doubles, these interior lists. What does the type of element get deduced to be? Just double, right? Because I'm moving through a vector of doubles, so my type over here must be the double. Do you guys understand why I'm using const here? I don't want to change it, right? I'm just reading it. So if I'm not planning on changing it, use const, right? I'm using a reference because I don't want to copy it, right? So we're going to write two more functions. Void add in place, which we could do this 2 different ways. A matrix reference M1 and then a double val. So over here, what I want to do is I want to add val to every single element inside the matrix. Does that make sense? And I might want to change this guy's name to be add scalar. And so notice the way that I did this is I clicked on the name of my function and did Shift F6. And so this will allow me to change its name. So I'll change it here. But if we pop back over here in matrix.h, it also changed, which is a pretty nice thing to know. So if you need to change the name of a variable, click on the variable, it's Shift F6, or you right-click, refactor, rename. This will rename that variable wherever it appears at. You can also do Control F6 or right-click, refactor, change signature. And this will allow you to change the return type of your function, add new elements to the function, remove elements from the remove arguments from the function, reorder the arguments to the function, and it's pretty convenient, which it will allow you to, fix things if you decide to change things around, and you'll have to change it in one place instead of having to change it everywhere that you use the function. So how do I go about adding value to every element in the matrix? Yeah, just another for loop, right? For, iterator-based for loop, range-based for loop, element-based for loop, element, indexed, iterator. I would use the element one right here. So for what? Auto reference row in M1. For auto reference element in row, row plus equals val. Not row, element. Yeah. We wouldn't want to use const here because notice I want to be able to change the element, right? If I use const here, it's going to say, hey, you can't add to that value because it's constant. if we use const back up here, we're also going to end up with that value, the error, because now I can't change the elements inside the row. So no constant here. Any other questions? And then again, maybe this guy's name is not good. We'll change it to be matrix. Great. Then you might just have like a matrix add scalar. So over here, we might make a copy. So you might have a matrix called result, who is a copy of matrix. And then we just do add scalar in place to results. And then we can return the result. Yeah. So you want to do an iterator-based for loop? Sure, we'll do that in 1 second. Let's say over here, I'm going to maybe we won't do that right here. So this function over here should read the elements from the user who's going to be entering in a matrix that's num rows by num calls big. The first thing that we're going to do is create a matrix, which again, this is a vector of vectors, so I don't have to keep typing that type out. Matrix. And so here we're going to use a different type of constructor. We're going to use the value-based one. So I'm going to say I want it to be num rows big to begin with, right? And then you could leave one as each uninitialized, but I'm also going to have each one be num calls 0. Let me see. Big, each of those. Do it again. Oh, I see what the issue is right here. Yeah, this should just be so this might look like a confusing expression over here. But what this is saying is I'm trying to create a matrix that's num rows big, right? Then I have to specify, well, what do I want each of those rows to be initialized to? Well, I want each of them to be initialized to a vector of doubles that's num calls big, who starts out as having the value 0. Any questions here in this line? So now what we could do if we wanted to use that iterator-based for loop, we could say for auto row iter is equal to matrix dot begin. Row iter doesn't equal matrix dot end plus plus iter. Row iter. For auto call iter equals row iter. Oops. So you guys are seeing the arrow operator for the first time. And so if we have something that's like x arrow y, that's the same thing as doing star x dot y. So here I'm dereferencing iterator to actually get to the element that's referring to, that row. And then I'm calling that row's begin method. Right, dot begin. So now what we would do over here is we would do std::cn into star call iter, and that would allow us to read that in from the user. And then at the end we return matrix. Any questions here? Slide that over. Yeah. So the star means to access the value that the iterator is on, right? So currently I'm referring to some particular row, and to get that actual row, I have to dereference the iterator, which is what's happening over here with the arrow. And then I'm accessing its begin method. We'll continue to go over things on Monday, and eventually we'll get to the point where we know how to do everything.
Have a good one.
Oh, you too. Yeah.
I just have like really basic questions because I just get confused with like the syntax and like coming from like Python.
Yeah.
So like if you go back up all the way, it's like matrix like sum. Like what is that saying? Like is that?
So I'm declaring a new variable whose name is sum. Its type is matrix.
Okay.
And it will be a copy of M1.
Okay. So like for C++, whenever you like declare a variable, you have to declare its type before that. Okay.
Correct.
Because I was like wondering what the conversion is. And the dot at I, what does that mean exactly?
So this is sum.
Okay.
Right. We're indexing at this.
The indexing
in row.
Right.
And then the jth element in that row.
Right.
But the dot at is a little bit better to use because if we accidentally went out of bounds, the at will check it for us and tell us that you went out of bounds.
Okay.
So have you ever had like a vector or a list in Python where you went out of bounds and
right.
it said like out of range issue? Now the dot at gives you that same warning.
Okay.
Using the square brackets wouldn't give us that warning if we did happen to go out of bounds.
Got it.
So that's why it's not as useful. And I don't know if you read this in your head. I always read this as at inside my head.
Yeah.
Sum at I j. Right. So now we have the sum at I dot at j.
Okay. Got it. Okay. Thanks, Professor.
What are the differences?
So
how do you know?
The header file is over here, right? This is .h1. It has the declarations.
So the other ones are
the definitions. The CPP has the corresponding definitions for that file. So here I'm just declaring things like, matrix is going to be this. Yeah, I mean, that's normally where I start. I write the declaration for my function, and then I go back over here into the CPP file, and I make its definition.
So you wouldn't be able to have it on.
So you could technically have it on one file as long as it was only included a single time, but I'm not going to recommend doing that because it's going to screw you in the long run.
Yeah.
Mm-hmm.
I don't understand why. So we don't have unsigned integer that is comparing signed integer.
Because size returns an unsigned integer, and right. So this function, whatever this result, this is an unsigned integer.
So about unsigned integer, is that positive numbers only?
It's 0 and larger. So no negative numbers.
Alright.
Mm-hmm. I have a simple remove space function, and it doesn't allow me to do the. So for Although I equals beginning, I is not equal
Okay.
to end, I plus
So the reason for this is, what is the type of I?
I is an iterator.
An iterator, right? And if we want to get the value that the iterator is at, what do we do?
String brackets.
No, right? If you want to get the value the iterator is at, you have to the star in front of it. Right? Because think about, like, the iterator is the position in the string.
Yeah.
If you want the value at that position,
You got
you have,
star.
you have to put the star in front of it.
Okay, and then erase. Can I just do erase I, or I have to?
So remember, like, I as an iterator is a position.
Which means I have to.
No. You don't want to erase the, like, so when you give erase, you do give erase an iterator. It's the position of the thing that you want to remove.
Oh, okay.
So this is correct.
Okay.
Right? One thing to note is that this code will not work correctly all the time. I said earlier in class, right, if you erase an element or insert an element into a string or into a vector, any iterators you have are no longer valid. Right?
Okay.
So you just erase an element here, right? This means that I is no longer going to be used. So like what you have to do to make this work is like start like I equals string dot begin or something.
So you'll have like a new start basically.
Yeah, or I think if you look at I'd have to go look at the documentation for erase, but erase might return an iterator to like the thing beyond where you just erased. Okay. So you might be able to say like iterator equals erase, but I'd have to check the documentation.
So basically you'll have to start after the...
Yeah, because like erase moves things around, right? So if I'm currently like this is my string, like A, here's I right now, and let's say we delete B. What happens is but I is still probably right here. But it's not guaranteed to be right there. It might be some random location. Okay. Right? So the iterator is not good after the removal is happened.
Okay. So if I make it come back to the beginning?
At the beginning it would be fine. Or, and again, I have to see the documentation of erase.
To see if there's like an option to start from that point.
Yeah, like erase might give you back an iterator. Or one thing that you might find useful is there's, in the algorithm library, there's a function called remove. And so you give remove two iterators, an iterator start at, an iterator end at, and you give it a value. And it removes all occurrences of that value in that range. So if you wanted to remove all the spaces in your string, you'd probably want to use remove. It's the easiest way to do it, right? But then you have to erase afterwards. Because it just moves elements around. Actually. Yeah.
I actually can compare operators. Today you have from 2 to 3, right?